Hello students, how are you today? I'm fine, thank you. My name is Tamasken Tanna. Today's unit is Unit 5, the periodic classification of elements. The periodic classification First, let us discuss about historical development of the periodic classification of elements. Historical development of elements. The law of traits. The first serious attempt to classify elements made by the German chemist Johann Doberner in 1817. Doberner arranged similar elements in 3 groups or traits. He observed that the atomic mass of the middle element is equal to the average of the other 2. For example, the atomic mass of lithium is 7. The atomic mass of sodium is 23. The atomic mass of potassium is 39. Therefore, the average atomic mass is 7 plus 39 divided by 2. So the result is 23. 23 is the mass number of sodium. The mass number of sodium. The second attempt to classify was made by an English scientist, John Newlands. In 1863, Newlands arranged the known elements in order to increasing atomic mass. The most successful to classify elements was made by a Russian chemist, Dmitry Mendeleev, in 1869. In 1869, Mendeleev arranged the known elements in order to increasing atomic mass. Mendeleev arranged the known elements in order to increasing atomic mass. In Mendeleev periodic table, the elements are arranged in order to increasing atomic mass. That means in Mendeleev periodic table, the basis for the classification of elements is atomic mass. He arranged the elements in order to increasing atomic mass. In order to increasing atomic mass. Therefore, Mendeleev periodic table and its law states that the property of elements are periodic function of their atomic mass. I told you, in Mendeleev periodic table, the elements are arranged in order to increasing atomic mass. That means, in this classification, the basis for the classification of elements is atomic mass. Students, next we'll discuss about the modern periodic table. The modern periodic table. The modern periodic table. I told you, Mendeleev arranged the elements in order to increasing atomic mass. Mendeleev periodic table has a great role to the development of the modern periodic table. But it has some defects or shortcoming. For example, wrong order of the atomic mass of some elements like argon and potassium, tellurium and iodine, and also the position of isotopes in the periodic table. So, in the year 1913, Henry Moseley an English physicist discovered a new property of elements. This fundamental property of elements is known as atomic number. Students, in Unit 4, we will discuss. In Unit 4, we have learned about atomic number. What is atomic number? Atomic number is the number of protons present in the nucleus of an atom. Each element has its own atomic number. The atomic number of one element is different from the atomic number of another element. So, I told you, in the year 1913, Henry Moseley, an English physicist, discovered atomic number. So, in the modern periodic table, elements are arranged in order to increasing atomic number. Modern periodic table and its law states that the property of elements are periodic function of their atomic number. Next, we will discuss about the structure of the modern periodic table. A structure of modern periodic table. Modern periodic tables are classified into periods and groups. Periods. The horizontal rows of elements in the periodic table are called periods. The horizontal rows of elements in the periodic table are called periods. There are 7 periods in the periodic table. There are 7 periods in the periodic table. Periods are represented by Arabic number 1, 2, 3, and so on. Arabic number. It is represented by Arabic number like 1, 2, 3. Each period consists of a certain number of elements. Each period consists of a certain number of elements. Each period consists of a certain number of elements. Period 1 which consists of or contains 2 elements. Period 2 contains 8 elements. Period 3 contains 18 elements. Period 4, period 3, which consists of 8 elements. Period 3, which consists of 8 elements. Period 4 contains 18 elements. Period 5, which contain also 18 elements. Period 6 contains 32 elements. Period 7, this period is incomplete period. Incomplete period. Period 7 is incomplete period. Next, we'll discuss about groups. 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 The vertical columns of elements in the periodic table are called groups. The vertical column. The vertical columns of elements in the periodic table are called groups. There are 8 main groups in the periodic table. Main group or a group. Subgroup. B groups. Main groups are from 1A up to 8A. Group number are represented by Roman numerals. I told you pair number are represented by Arabic number, but group number are represented by Roman numerals. Roman numerals. So B group from 1B up to 8b. Group B, they are called transition elements. Transition elements. Transition elements. Transition elements are found between in group 2 and group 3 or at the center of the periodic table. All transition elements are metals. All transition elements are metals. Main group or A groups have common names or family names. Group A or main group have common names or family name. Group 1 elements, they are called alkali metals. They are called alkali metals. Group 2A, they are called alkaline earth metals. Group 3A, they are called boron family. Group 4A, they are called carbon family. Group 5A, nitrogen family. Group 6A, they are called chalcogen or oxygen family. Group 7A, they are halogens. Halogens or salt formers elements, or halogens means salt formers or salt makers. Group 8, they are noble gases. They are noble gases or inactive gas. They are inert gas. So group A or main group elements have common names or family names. So group 1 element, alkali metals. Group 2 element, alkaline earth metals. Group 3A, boron family. Group 4A, carbon family. Group 5A, nitrogen family. Group 7A, oxygen family. Group 7A, halogens. And group 8, noble gases. Now let us discuss about electronic configuration and arrangement of elements in the periodic table. electronic configuration and arrangement of elements in the periodic table. Students, remember that you have learned electronic configuration. The arrangement of electrons in various shell or energy level is known as electronic configuration. Electronic configuration of an element helps to determine the group number and period number of the elements. By using electronic configuration, tells us group number and period number. Period number. Period number is equal to number of shell. Elements in the same period have the same number of shell. Elements in the same period have the same number of shell. That means period number is equal to number of shell. For example, if an atom has, if an element has two shells, if an element has two shells, it is found in period 2. Period 2. Period 2. If an element has three shells, it is found in period 3. That means number of shell tells us period number. Period number. For example, carbon, its atomic number is 6. So its electronic configuration is 2,4. Therefore, carbon has two shells, K shell and L shell. So carbon is found in period 2 because it has two shells. Another example, sodium. Its atomic number is 11. Its atomic number is 11. So first write its electronic configuration of sodium. So its electronic configuration is 2, 8, 1. Therefore, sodium has three shells, K, L, and M. Therefore, sodium is found in period 3. Period 3. So students, try to answer the following questions. To which period does an element to which period does an element with atomic number 16 belongs? To which period does an element with atomic number 16 belongs? So first, write the electronic configuration of the element. So its electronic configuration is 2, 8, 6. So the element has 3 shells, K, L, and M. So it is found in period 3. Okay, students, I think this is the end of our lesson. Next we'll join again. Goodbye, everyone.